Okay, grade 9s, today we are going to talk about the rule of 4. Now, the rule of 4 is something that you may have seen mentioned already in the textbook. It connects and tries to bring together all of the things that we've been talking about in this unit on linear relations. And the idea of the rule of 4 is that depending on the information you're given for a particular question or scenario or example, that you can sort of restate or express the information in one of 4 different ways. And as you can see on the screen here, the 4 different ways that you could express information about a linear relation would be description. And by description, all we mean is like words or a sentence that describes the problem. Table, as in a table of values, like a t-chart. Equation, often written in or written as a direct variation equation or as a partial variation equation. And then finally a graph. And of course there would be a horizontal axis and a vertical axis on your graph. So for this example we're going to work on here today, we are given one of the 4 pieces of information, and our job is to fill in the other 3 pieces of information, to express this graph in the 3 other ways that go along with the rule of 4. Now where we begin with this is totally up to us. If we are given a graph, there could definitely be someone who thinks that, hey, if I have a graph, then the next thing I want to do is fill in a table of values. And for a particular person, that certainly may work for them. Somebody else might say, well, gosh, if you give me a graph, I'm really good at going in now writing the equation. And that certainly might be true. And maybe for a third person, they would say, if you give me the graph, the next thing I can do is write you a description of the problem that the graph is representing. And so there is no perfect place to begin this problem. It really depends on you, the individual. Now for me, because I'm the one, I guess, leading you through this example, when I have a graph, my first instinct is to fill in a table of values. And so again, when we talk about table of values, we are talking about a t-chart, and often shown as x and y. Now just to be clear, along the x-axis in this graph is the airtime usage for this cell phone bill. Now by airtime usage we mean like when you use your phone as a phone, like for actually calling somebody and talking to them. So it would be totally fine to also state that this is the minutes and that y is representing here the total charge or the total cost of your cell phone bill. So I'm just going to write that over here, total charge. And now we go about filling in the table of values. So all we need to do here is begin looking at the graph, and we don't even have to record down values in our table for every single blue dot that we see. But we do certainly want to get a collection of dots that we are very confident in, that we are very sure of, and put them into our table. So the first dot I see is when there's 0 minutes, the total charge is $30. That already gets me thinking, by the way, about things like the equation and the description. Just that one row, like what does that row mean? What does it really say in words as it relates to minutes of airtime compared to total charge? But you know, we'll wait for those things once we go to fill in those boxes. The next dot I see, I couldn't tell you for sure where this dot is located. And I don't want to guess. So you know what? I'm not even going to put it in my table. I'm actually just going to leave a blank spot. Perhaps after I get a couple more dots that I know of for sure, I might be able to actually figure it out, given that this is a linear relation. The next dot that I see that I think I am confident in is the ordered pair that's 20 minutes and $35. Now, as I look at that dot, it's natural to wonder, well, geez, 20. I'm confident that it's 20 minutes, but how do I know it's not $34 or $34.50? I am sort of guessing at this 35 and I'm going to keep it in there, but I'm still not totally confident in that. The next order pair at looks like maybe 30 and I don't know, somewhere between 35 and 40. I'm going to go right to the 40 and 40. Now, we know this about linear relations, that because there is a constant first difference in the y column and the x column, I can actually figure out what is 10 and what is 30. I can look at this table of values and then of course verify with my graph that, you know what, 10 minutes would have to be $32.50, right? Things have to change by the same amount in both columns. So if the minutes column is going up by 10 each time, then the y column has to go up by the same amount each time as well, and 32.50 makes that fit. In a similar way, what's the missing value that goes with 30 minutes? What's it going to be? Well, what's halfway between 35 and 40? 37.50. And even though I don't have the rest of my table written down, this is good enough for now. Okay, I could certainly make more room and put more rows in my table, but you know, for the purposes of what we're doing here, this is totally good. All right, after I've made my table now, I can move on to either description or equation. And I think what I'm going to do is I'm going to try and come up with the description. The description box is often the hardest one for students to fill in because you know, it's kind of hard to put words to something. So I'm going to look at my graph. It's about a cell phone bill, okay? I know that because that's the title of the graph. It's airtime compared to total charge. So when coming up with the words to this problem, I'm definitely going to have to mention that it's a cell phone bill, and that the, you know, like I guess how much it is like per minute or you know, where it starts at or something like that. And so actually, I'm actually pausing right now and I'm thinking to myself, I don't want to do the description right now. Some of the information I would need to put in there, I don't have. I'm actually going to go to the equation next. So I'm just going to change my mind. I'm going to go to the equation. Looking at the graph, this is a partial variation. I know that partial variation equations look like this, where m is the rate of change and b is the vertical intercept. So in filling in the specific values for m and for b, I know that the initial value, the starting amount, is 30. I'm going to replace b with 30 right now. X and y are the variables, right? X representing the air time and y representing the total charge. So now what I got to figure out is, what is the rate of change? And I can certainly either use the graph to help me figure out the rate of change, or I could use the table at this point. If I use the graph, I'm probably going to use something like rise over run to figure out the rate of change. If I'm using the table, I might either use the subtraction method or the first differences method for figuring out the rate of change. But the rate of change here is the cost per minute. So I'm going to use the graph. I like graphs, they're very visual. I'm a visual learner, so I'm going to use the graph. Now, how do I use the graph? Well, what I need to do is I need to find two order pairs on this graph that I'm really, really confident in. That I, you know, would bet money that I know what they are. The first order pair I'm going to use is this one right here. Whoops, hang on a second, I got to change my pen. I'm going to use this order pair, 0 and 30. Very, very easy to see. I'm confident. I'm also very confident in this order pair right here at 40 and 40. Now, I have to be very careful with my scale. This is like the biggest threat or the biggest risk when you're using rise and run, is that if the graph is not counting by you know, ones, you have to be very aware of that. So I'm going to rise, and then I'm going to run. And how much is the rise? How much is the run? Well, I can see that the rise is 10, right? It goes from 30 to 40. So let me just kind of sneak that in here. M equals rise over run. So I've got the rise as being 10, and the run as being 40. right? It goes from 0 minutes to 40 minutes. Now, I could certainly reduce this and keep it as a fraction, but in lowest terms. And I could take that value and go and put it into the equation right over here, okay? Because that's what m is, the slope, the rate of change. Or, as long as it's exact, I could change that to a decimal. So what's 1/4 as a decimal? If that's 0.25, that might be a more appropriate way, and certainly a more convenient way to express the slope than as a fraction. So I'm going to change that, and I'm going to put 0.25. All right, I've got the equation, and I've got the vertical intercept. All right, I've got the rate of change at 0.25. I've got the vertical intercept. It's 30. Now, as I go to write the words or the description for this problem, I really have to think about the meaning of the rate of change and the vertical intercept, because those words are going to need to end up in this description. So I'm going to say something like this. A cell phone bill is determined by charging an initial fee and a rate of change for each minute of air time. Yes, I am going to definitely change the size of my font so this fits way nicer in the box. Let's do that right now. Let me change my font size to something way smaller. Hey, that's way smaller. Okay. Alright, so what am I saying here? I'm saying... Alright, so a cell phone bill is determined by charging an initial fee and the rate of change for each minute of airtime. So this is where I have to go on to say the initial fee is $30 and the airtime charge is, and how would I express this? Well, this is 25 cents per minute, isn't it? So $0.25, so 25 cents per minute. For the words, that's pretty good, okay? There's no like perfect words to put in here. As much as you're trying to word it like it might be a problem that you might find like in the textbook or something like that, this is totally good what we have here, okay? It, of course, the words need to contain some information about the rate of change. The words also need to contain information about an initial fee if there is one, okay? I just realized I spelled airtime wrong, and some of you are going to criticize me for that, so there, okay. Oh, initials also spelled wrong. Oh, yikes. There we go, initial. There we go. All right. So, I mean, that's how you might fill in the words, is that you have to give context to the problem and almost think about it like what might a word problem sound like if it was given to me. You know, imagine you were, instead of this question, you were given a different rule of 4 question, but all you were given was the description. What would the description have to say for you to be able to fill in information about the table or the equation or the graph, okay? So this is probably the one that you're going to find most challenging, is the description, but you know, this is what you're trying to do. So overall, this is what we have. This is what we're trying to do here with the rule of 4, is we're trying to take some information about a linear relation, and we're trying to basically fill in the missing pieces, or the missing, I guess, other ways of expressing the linear relation. So this is what today's lesson is. Thank you very much. Bye.